Awesome. Thanks, guys. Yeah, so I'm just going to go into like more of an overview and probably not as in-depth as Web3.js, only because, to be quite honest, it is a little bit more complicated and requires a little bit more context to really get into protocol development. But this is just to give you a sort of introduction as to the kind of stuff that we do here. And of course, if it interests you more, we're always available on our ChainSafe Discord to chat with you guys and to help get you into understanding Lodestar and our libraries a bit more, and also protocol over at Ethereum. So we have a team of 8 full-time engineers right now, and myself as the project manager. These are the guys that are currently helping to lead and build Lodestar and contributing back to the Ethereum core protocol community. So what is Ethereum protocol? It is basically the underlying, what some people will call layer 1 of Ethereum. And it's basically the stuff that we do to keep the blockchain alive. So in very high level terms, the kind of stuff that we deal with here at layer 1 of Ethereum is in regards to the execution layer, which is basically like, the world state of Ethereum. And then Lodestar specifically, we work on the consensus layer, which is basically how do we maintain consensus of the blockchain, and how do we keep the canonical block. So if you're ever interested in learning more about Ethereum protocol development, this book at eth2book.info is maintained by a previous core dev over at Teku. And it explains everything in technical terms. It's still a work in progress, but it'll give you a good start to understanding some of the blockchain primitives of what allows Ethereum to function at its current state as a proof of stake system. So very simply, we have an execution layer node, which you may have heard of, called Geth or Nethermind or Besu. And then we have consensus layer beacon nodes, one of them being Lodestar, but you may have heard of things like Prism or Lighthouse as well. And together, these are linked together by an engine API, which allows an Ethereum node to basically function. This is a very high-level overview of that, but what we work on implements the beacon chain consensus algorithm. So this is where most of our work entails, but we do work very closely with other parts of the community, including researchers and other client teams, which you may have heard of. So what you would do, this stuff, well, I'll get into that afterwards, but why is Lodestar important? Well, you may have heard of something called client diversity. And the great thing about Lodestar is that it's written in TypeScript. So it's very accessible to a lot of developers who wish to get into protocol development. There is an easier way into helping Ethereum protocol without having to, learn Go or Rust, and basically being able to help us integrate better into the Ethereum protocol ecosystem, because all of our libraries and stuff are basically written in TypeScript as well. So we provide some of the tooling that developers will need to interact with Ethereum protocol. So we contribute to client diversity. We are the smallest right now of the 4 consensus clients in terms of usage. So there's a lot of room here for improving client diversity. So if you are a staker, or if you've ever done anything in relation to that, run Lodestar. So what is Lodestar used for? Well, keeping Ethereum resilient, because altogether these client teams basically is what keeps the blockchain running. So here are the different consensus clients that I've laid out here. As an example, we are the TypeScript client, and yeah, those other ones exist. The other cool thing is if you're looking for more than just dApp development, smart contract development, we do a lot of research and development. We're the people contributing to Ethereum specifications, doing research on basically Ethereum roadmap initiatives. So if you're looking to get really, really deep into how the blockchain functions, there's definitely room for you to contribute in Ethereum protocol. So we're, leading initiatives such as like Verkle testnets as a good example. So down the road, hopefully within the next year or 2 years, Ethereum will hopefully migrate from a Merkle Patricia tree over to a Verkle tree. And being able to do these things requires quite a bit of effort, involving research, involving implementations. And what we're really good for here at Lodestar is actually being able to implement these proof of concepts pretty quickly for R&D testing. So that's a good use case for Lodestar. If you've ever done staking, you probably would have heard of a new trend, basically distributed validator technology for people who don't have 32 ETH to basically stake for their own validators. So, we're helping to lead some roadmap initiatives there. And this would be another use case for something like Lodestar if you're looking to understand how to better contribute to distributed validator technology. So what's it like to be a protocol engineer at a very high level? Well, we do a lot of the work that maybe not a lot of people may be interested in, but if you're looking for a challenge, building and contributing to Ethereum L1 is very rewarding. So if you understand a little bit about the EIPs and different things, like when we do hard fork upgrades of Ethereum mainnets, these are the kind of things that we contribute to in regards to research and specifications, and then implementing it into clients like ours. So that is one of the things that you would do as a protocol engineer. The other thing, of course, is maintaining the beacon node and the validator client, which are the two things that Lodestar has. You would be basically doing a lot of performance testing on our clients. Deneb added a new functionality called blobs, which I can go into a bit later. But these sort of new things as well, we need to make sure is compatible, but also performant in our beacon node implementation. So you'd be dealing with a lot of metrics kind of stuff, analyzing a lot of that. I can show you a screenshot of that afterwards. Dealing with technical debt, if you're interested in how blocks are encoded on the chain, understanding simple serialize will basically be the kind of things that you would be doing here. Doing upgrades in terms of even the network stack that we use. We're currently using JSLib-P2P. And then we have, if you're looking to get really deep into networking, we're implementing Yamux, which is a multiplexer for the network, and also looking to implement a protocol called Quick. So if you're really into these kinds of things, that's where you can really help contribute. Of course, there's also a nice focus on improving our developer experience. When it comes to protocol, it's not usually, the most developer-friendly thing as well. But, there's always a lot of room for us to even have a Santiago on our team as an example to be able to help people not just get into protocol development, but also helping us to maintain our client implementation. So, here's a screenshot of one of the dashboards that we use very often, which very much shows you the kind of importance and data capture and analysis that we do with a client implementation like Lodestar. You would be, testing your branches and stuff with our infrastructure that would, show us how performance these changes and things are, how it affects different aspects of the beacon node when you are developing on Lodestar. So, like I said, it's not always easy, but it is very rewarding. So I'm just here to give you a very high level of what it's like to be a protocol engineer for Ethereum. You can get cool Git POAPs like this 2023 Lodestar contributor badge. Basically making PRs in our repo will qualify you for stuff like that. And then I'll go into our issues a little bit just to give you a high level. So more importantly, though, contributing to ecosystem libraries and tooling is really important because that's kind of what allows us to also connect to other layers of the stack. Things like Web3 JS would, if they ever needed any sort of beacon-related data, would plug into something and pull calls from our APIs, our beacon APIs at Lodestar. We are the probably the most used consumer of JS libby2p. So if you don't know, libby2p is the networking stack that we use for Ethereum, consensus specifically, yeah. So these are the kind of things that like you would, if you had any curiosity in looking at and contributing, understanding simple serialize. We have an SSZ library over in our ChainSafe repo. And of course, the consensus specs that maintain, consensus and the rules regarding that is all within the Ethereum repo. And, we actively contribute to stuff like that as well. So I'm just going to very quickly, high level, show you some of the types of issues that you could encounter if you do wish to contribute to Lodestar. The easiest way, of course, is just to join our ChainSafe Discord and find us in the Lodestar developer channel. We can always help you understand some of these first issues that you could try your hand at. So under ChainSafe Lodestar, just under the good first issues, there are definitely things here. You can see like a lot of them are very much like API driven or, just helping us to fix things that are still broken on Lodestar. But this will give you a good idea as to how the specification works, because what we do is we develop the client to follow these specifications in the Ethereum consensus specs repo or the Beacon APIs repo. And you can see there's still a lot of like tech debt, which you would be able to help us with. The other big push, of course, is to help us improve documentation. And the best way to improve documentation is, of course, learning and understanding how Lodestar works. So we would be able to help you with stuff like that. One of the things that is very interesting, though, that we've developed recently, which may touch more of like a Web3.js level as part of the stack, would be like our Lodestar prover. So Lodestar prover is basically like a Web3 provider, it can act as a proxy to allow you to basically be able to utilize Web3.js or Ethers.js or whatever your Web3 provider of choice to utilize the light client specifications on Ethereum to prove that something is true. So whether that be like an account balance or anything like that, these are currently some of the Web3 methods that we support right now. So if you do want to get, a little bit hands-on and a little bit dirty on some of the light client stuff with Lodestar, that's always like a good touch point that touches a little bit more of maybe like a dApp developer user. The other cool stuff to probably check out here is, like some of the dependencies that we have. So I mentioned JS libby2p. This is the networking stack that we use, and we regularly contribute to stuff like this. If you're curious about some of the cryptography that we use, we have like a BLSTS, which is a TypeScript wrapper for the BLS library. So we maintain stuff like this so that we're able to basically have the cryptography that we need to function on Ethereum protocol. If you have any curiosities, or if you're really keen on contributing to Ethereum protocol, the Ethereum Foundation does have like a protocol fellowship program as well, which a lot of people do come to, and some of them eventually find work with some of the client teams or other people in core development. And to give you an example of like some of the stuff that people have worked on, you can see the type of problems that people are kind of dealing with as protocol engineers. So if any of this kind of stuff interests you, Lodestar is definitely a good way in. And I think that's pretty much it. I hope I gave a good enough like high level understanding of what Lodestar kind of does and what we do for Ethereum protocol. I'm just gonna take a quick look at the comments and stuff here. So I did not get a chance to read that while I was presenting. So if you have any other questions, feel free to post them.
Yeah, definitely. Thanks, Phil. Great overview of what you guys are all working on with the Lodestar team. If anyone has questions, feel free to drop them in chat. There were a lot of questions coming in already about running a node, how that works with the underlying protocol. I think we've covered most, but it might be good to highlight on the difference between validators and just running a full node and how that still impacts the resilience of the network, even without staking that 32 ETH, which is obviously a high cost for a lot of people.
Yeah, that's right. So actually running a full node, you can probably just do it on a device as small as like a Raspberry Pi. Obviously, like you know, the higher computing hardware that you can get access to, the better. But it is possible to run a full node and just get access to the data that you need to, like maybe if you're running your own local node to test against as a developer as well. But that does not require you to have to run a validator. So just to be clear, there is a difference between running your own node and actually validating. By having a full node, you basically get, you know, access to Ethereum through your own trusted device without having to go through providers. You won't be able to attest to, say, you know, the head of the blockchain or help finalize the network or anything like that. But that's not, you know, you don't need 32 ETH to participate in running your own node. And in fact, running your own node does improve the resiliency of Ethereum. Having more peers on the network, more diverse peers on the network is definitely helpful to the resiliency of Ethereum.
Cool. Yeah. Thanks for summarizing this. We have been discussing that for a bit during your presentation. So great to hear. Let me check if there were any other questions. I think you covered most of it. Running on Raspberry Pi, resilience as well. Question from Uttam. Go ahead.
Yep. Hey, Philip. Thanks for the presentation. Amazing. I do have a question regarding the. So recently there was a bug in the Nethermint client, right? And after that, the community was like, "Hey, we need client diversity and all." So I'm just wondering, what if now there is, maybe in the future it is possible to have a bug in consensus client. So what usually is the process? So suppose there is a bug, you know, people find out. So what usually happens? Like, what's the process flow of a company, or like you guys running the client? So what happens inside the team? I just want to know that.
Yeah, so generally, you know, we're really good at working together as a core protocol dev community to help diagnose and help each other come down to an analysis of what was actually happening. So generally, if, you know, a client team is proposing invalid blocks on the network, so that would be something similar, I guess, to the Nethermind bug. You know, everybody has a node running on the network collecting this information, and we're usually pretty good at figuring out what, like where the block is coming from, what clients they're running, what versions, and then being able to be like, hey, Nethermind, you know, we're finding that there's a lot of rejected or invalid blocks coming from nodes running Nethermind. Usually what will happen is, you know, the teams will get together, they'll diagnose it. But the most important thing is that Nethermind is a minority client. So at the end of the day, the network is able to still continue on finalizing the network and just rejecting their blocks. Now, this would be a very different story if Nethermind was something like Geth, which has about like close to 80% of the network from, you know, the estimations that people are seeing. Understanding how the blockchain sort of primitive works, if you have a majority client, so you have more than 66% or 2/3 of people voting that an invalid block is actually correct, that's where you'll see a very, very big problem. So this is why, you know, the Nethermind bug is definitely critical, but it didn't affect the network as a whole super negatively, because without having that 66% attesting that Nethermind's blocks are actually valid when they're actually not invalid, or sorry, they're actually invalid. We never had a chance of finalizing something that should not have been finalized. So this is why a lot of people in the community are pushing for client diversity. And this is why it's super important to ensure no client team can have a super majority sort of use on mainnet. And then, of course, like that gives the core devs a lot more time to actually diagnose and come out with fixes for their problems. Because at the end of the day, you know, we obviously do our best to ensure that we don't ever have any consensus type issues. But, you know, sometimes things slip through, and you can see with the Nethermind bug that, you know, the worst thing that happened was that anybody running Nethermind at the time was just not able to continue with validating the chain until they had the patched version.
Yep. Okay, that's helpful. Thank you.
Cool, thank you. There was another question here. I think you briefly answered it already, but protocol development could be a bit complex, but how steep is the learning curve? I think you mentioned this as well already. I mean, it really depends on your background and experience, I guess. So it's hard to give a definite answer on this, but Phil just mentioned this as well, and I want to highlight that again as well, that there is a program called the Ethereum Protocol Fellowship. It's organized by the EF, but with a lot of support from the ecosystem and client teams like Lodestar. They just announced today, actually, that they're running study groups first before the next cohort. I think the next cohort starts mid-April, late April. And the study groups, I have to check, but soon, in between at least. So it actually is used to fill that gap and prepare for solid basis so you can enjoy the fellowship program as well. I see you shared the link already, Philip. That's great. Thank you. Any other thoughts from you on that?
I would highly recommend that if you do have an interest in protocol development to try to participate in something like the EPF study group. I think that gives you like definitely a leg up when joining a team like Lodestar, when you have an understanding of the protocol, because we do deal with not just Ethereum related problems, but also Lodestar related problems and issues in regards to the node implementation itself. So, you know, there are, you know, people on our team who are much better with navigating around Node.js and that backend over necessarily understanding all aspects of the Ethereum protocol. So there's definitely, the reason why Lodestar can be complicated for people to start is because there's just so many different pieces. And I would even say right now that even some of our senior contributors at Lodestar don't understand everything about Lodestar or the Ethereum protocol. So, you know, it's really just teamwork and making sure that we cover our bases everywhere.
Yeah, that's definitely true. That's a good one to highlight as well. The space is growing so fast that it's hard to know everything, every piece of the stack in detail. I doubt anyone at this point still working in the ecosystem does. So you need everyone, you need each other, you need consensus client teams and the execution client teams, but also working on the spec, on other things, on the utilities, on the tools, etc. So definitely it is teamwork. Maybe we are running a bit late already because of some delays, but I want to ask maybe a last question, or because blobs are coming. I just saw the announcement as well that the date is set for mainnet. March 13, very excited. I'm sure you guys have been busy and excited for this as well. It's a big step for scaling Ethereum, and I'm sure you've all been busy and involved with that as well. We're not there yet, but congrats on the progress so far. Maybe you can share a very quick overview of what's next on the roadmap, what's coming after Denkun.
Yeah, so actually there's a lot of deliberation. If you do follow any of the Ethereum core dev calls, There's a couple of cleanup items that are in there, but there's still actually discussion in regards to what gets included in the next hard fork. But some of the biggest things to really follow along is there's a strong push for data availability sampling, and there is like a very simple version that they managed to spec out called PeerDAS that will affect us as a consensus client team the most, which really helps with basically data space because we know how important that is on a blockchain. As we've heard from a lot of people in the community, it seems like scalability and lower gas fees or transaction fees are super important for a lot of builders and users of Ethereum. So that is one of those things that we're really dedicated on focusing on. There's other things like proposer builder separation. If you're interested in understanding how we separate validators from proposers and from relays, that's also another big thing that is undergoing research. There's a lot of people doing things like zero knowledge EVMs. There's just so much happening. I can't really say for sure what's going to get included in the next hard fork, but I can tell you right now that the blobs are coming, and they will be very, very useful, especially if you plan to do any work on L2s. So if you're developing dApps or anything on L2s, you're going to see a significant reduction in terms of fees by utilizing things like Optimism, OP stack related L2s, like Base is one of them, or even things like Arbitrum. So that's really where the most benefit is going to come starting from March 13th forward.
That's great. Thank you. Yeah, and good to mention that as well. Indeed, there's definitely a lot of opportunity right now. A new design space maybe as well. Lowering transaction costs for L2, which just opens up new use cases and new exciting opportunities again to work on as well. Great. Thank you. Thanks again, Phil. Thanks again, Santiago as well. I see no other questions coming in anymore. So I think we're gonna wrap things up here. So clap, clap, clap. Make people excited. Cool. Cool. Thanks again for joining, guys. It was a pleasure to have you, and hope to see you all soon.
Thank you. Thank you, everyone.
Thank you, everyone.
Thank you, everyone.